Hey everyone, this is Mrs. Hilt with your mini lecture on units of measurement and introduction to the metric system. All right, so what is a measurement? A measurement is a quantity that has both a number and a unit. And whenever you guys take or record a measurement, you must have both a number and a unit associated. So for example, if I asked you guys to take the volume of this Diet Coke can, I would expect you guys to record an answer of either 12 fluid ounces or 355 milliliters. Both of those quantities have a number and a unit associated. And every measurement that you guys give in this class also must be recorded to the correct number of significant figures. The significant figures mini lesson will be in a different video, however. The system of units that we use is the International System of Units, or SI. I know it seems like it should be IS, but just because of language translations, it comes up backwards in English. But the SI units are a measurement system used by scientists and engineers all around the world. That way we can compare data or measurements in an easier way if we all have the same system. And why is the SI system used? It's because it differs by a power of 10. So you have a base measurement, and then all of the units that are larger or smaller than that base unit differ by 10. And that makes the converting between those units pretty simple because you move a decimal place left or right. So this list, the base units that you guys have to know for this class are the top 4: meters for length, kilogram for mass, second for time, and Kelvin for temperature. Okay. The other 3 listed here are also base units, but you will not need to know those for this specific class. And here's the scale I was talking about that is based on powers of 10. So as you can see, we actually have little powers written next to it, and all of those are just by moving a decimal place over, left or right, or dividing or multiplying by powers of 10. Here is the same scale, but at the bottom we have a saying: King Henry died by drinking chocolate milk, to help you guys remember the center block, starting with kilo for king and ending with milli for milk. And you guys can come up with your own or look some up that have the entire scale, starting with tera and going all the way down to pico. I know there's one that goes like tiny, green, men, but you guys can always make up your own that works with you. All right, so when you are converting, to convert a smaller unit, you move the decimal point to the right, and the number ends up getting bigger. Then if you're going the other direction, to convert a bigger unit, you move this decimal point to the left, and the number will get smaller. You can also use a staircase type method, where if you were maybe starting with centi and you wanted to go to kilo, you would move the decimal place 1, 2, 3, 4, 5 spots, and your number would end up looking smaller, but your unit will have gotten larger. All right, let's try out some practice. Okay, so if you're feeling confident, go ahead and pause the video and try out these practice problems shown right here. Okay, and I'm going to start going over the answers very shortly. So again, if you want to try these out on your own first, please pause the video now. Answers will start in 3, 2, 1. All right, so 11.036 milliliters going to deciliters. And we'll start at milli, and I'll go 1, 2, 3, 4 spots, and that means my decimal place is moving, 4 spots to the left. That would give me 0.001103.6. Okay. All right, next up, gigameters to centimeters. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that was 11 spaces to the right. Okay, so this is going to end up having a lot of zeros next to it. And I can see that in my number, there's only one, only one number to the right of the decimal. So I will end up just throwing 10 zeros after that 4. And that number is really, really big. So what you could do instead of writing all of those zeros is write it in scientific notation, which would be there we go. All right, now 26.22 deciseconds to milliseconds. I'm going to erase some of this stuff to make it a little easier to see. So going from decisecond to millisecond, 1, 2, only 2 spots, and we are going to the right again, 1, 2. Right, and last but not least, meters to megameters. So if you look at the scale, there is an M right here, but because this M is all by itself and there's not another M next to it, it is not millimeters for this one. Whenever you just see an M by itself, it is always the base unit meter, or if there's ever any just one letter, it's always the base unit. So we're going from meter to mega, 1, 2, 3, 4, 5, 6. And that means I will move my decimal place to the left. 1, 2, 3. All right, my decimal place kind of got messed up. Oops. There we go. All right. And one last comment is that for this first one that I did, I wrote a 0 in front of the decimal place, and the last one I did not. I did not do that on purpose. If you want to write a 0 before the decimal, that is totally fine. It does not add a significant figure. It's kind of just your preference if you want a 0 there or not. Okay. All right. Let me know if you guys have any questions. Thank you for watching.